So welcome to the CyberCon Manufacturing Cybersecurity panel. I'm Wayne Osted. I'm from the Idaho National Laboratory. I'm the Chief Technology Officer for National Security. I'd like to talk a little bit about the need for pervasive and proactive cybersecurity in manufacturing. And I think you'll find this panel that we have arranged very exciting and very topical for what's going on. If you look at the manufacturing sector, it's one of the most complex sectors out there with a myriad of small and large manufacturing entities, and the way it's interconnected between different product lines and chemical sector and intertwined with our power and energy sector, it's just extremely complex compared to the rest of the sectors. At the same time, it's also under severe attack. It's one of the leading sectors, attracting 27% of the cyber attacks currently, or at least across the different sectors in 2019. And the control system side of the attacks are up almost 2,000%. So you have a critical sector that feeds other critical sectors like medical and our bulk power system, which is the subject of a new executive order on supply chain security. And it's going to be a very hard sector in order to address consistently for cybersecurity. The second aspect associated with the manufacturing sector is securing automation and securing supply chains are inherent challenges that are interlinked. And what do we mean by that is that if you're securing your manufacturing floor associated with a particular steel product line, but you are getting supplied with motors or other controllers from other suppliers that are involved in your processing chain, unless you solve both aspects of that challenge, securing your own automation floor as well as your supply chain of components, be they electronic or material supplies, either for quality issues or for cybersecurity issues, you're really not addressing the problem. So you have layers of interconnectedness and you have layers of complexities that really make this sector extremely complex. The other aspect, which is very exciting but also complex, is we have a new wave of digital engineering that's crossing the life cycle associated with these plants. And so when you look at the way we design things nowadays, it's almost entirely digital and moving towards a unified mod and sim and engineering design environment. And so it's no longer a document that's exchanged between the different suppliers and components. What it really is often electronic design files that sometimes are actually loaded in the machine that's going to be manufacturing the device or the component or stamping out the various processes for making your electronics. So it's a really complex sector and a lot of opportunities to apply new cybersecurity technologies. If you look at historically how we've done that, my third point is we have a complexity and a mixture of architectures that are trying to address both the control loop side with industrial control systems, as well as a data-driven IT side. And when you combine those together, that's how we're forming these new OT technology architectures. And so with that, we have a myriad of protocols, a myriad of new data science techniques, and opportunities for all sorts of machine learning and mod and sim and digital engineering used in a lot of different ways. When combined in the wrong way or when using a mixture of these architectures, if you don't do it right, you may be creating attack surfaces which you wouldn't normally otherwise have. An example would be we have kind of a hierarchical model associated with our historical plant floor in which we assume that we have a certain amount of perimeter defenses all the way down to the controllers, whether it's firewalls or different layers between the control and sensors and the actuators. But with Internet of Things and industrial Internet of Things, we're purposely trying to bypass some of those layers in order to get a richness of data to suck it up into the cloud or into other modeling and sim engines. Implementing this increased connectivity really increases your attack surface if you don't look at it in terms of a real holistic and optimized architecture for both security and for the production qualities you're looking at. So my final point as we introduce this panel is that really the future is all about driving a more proactive and pervasive approach towards cybersecurity. And I think what you're going to find is necessary, and what you'll find this panel discussing is how we redefine the return on investment for cybersecurity in a different way so that it's not just treated like an add-on expense or an add-on burden. And I think you'll find some neat discussions about this from the Department of Energy and some of the other players on this panel. The other thing that we should look at as we are designing these new security mechanisms is that it'd be worthwhile to look at it in a holistic engineering approach when we're looking at not just the bits and bytes, but the physical actions being taken, as well as our energy consumption and our energy efficiency. I think you're going to find as the panel discussion goes on, there are opportunities to look across these different domains and optimize them for a different security and production efficiency posture. And finally, I'd say is that what we really need to do in order to make this much more pervasive and proactive is come up with those tools that are going to provide an adequate level of formalism that we can back with automated tools in order to validate the quality of the code, validate the ways in which we integrate these configurations, and validate the nature of the supply chain that we're feeding into our industrial plant floor. So with this, we've assembled a very neat panel that I think will be talking to you about how we create an innovation ecosystem for the nation to address this challenge in a very different way. So with this, I'll turn it over to Shawn Planke, who can talk to you more about the Cyber Manufacturing Innovation Institute.
All right, welcome everyone. I am Shawn Planke, the Principal Deputy Assistant Secretary of CSER at the Department of Energy. That's the Cybersecurity, Energy Security, and Emergency Response Section office in the Department of Energy. And we're here today talking about CyberCon, and we have a distinguished group of manufacturing professionals in the United States, cyber manufacturing professionals in the United States, to have a quick 1-hour conference to hear their thoughts on how we're going to move the needle on cybersecurity and manufacturing. So to run us through, I want to start with Chad. Chad's one of our leaders in advanced manufacturing. He's leading a mission to develop manufacturing processes and materials for the advanced energy sector. Chad, can you introduce yourself? Give us a quick byline.
Sure. Thanks, Shawn. Chad Shell, as Shawn mentioned, I'm with the Department of Energy's Advanced Manufacturing Office, which is a sub-office of our Energy Efficiency and Renewable Energy Office. I've been working in renewable energy and energy efficiency space for over 16 years, and you know, the Advanced Manufacturing Office is really focused on improving the U.S. manufacturing energy efficiency and competitiveness. As cybersecurity and connectivity becomes a bigger and bigger issue, that's becoming more and more relevant to keeping our U.S. manufacturing competitive. So, thanks, Shawn.
Thanks for being here. I appreciate it, and we look forward to digging in on that topic with you this hour. Now I want to pivot to Howard Grimes. Howard's over at the University of Texas, San Antonio, which is one of our leading locations for cyber advanced manufacturing. In particular, he's an award winner of the CyManII Award, which is a Department of Energy funding opportunity to grow cybersecurity in manufacturing. Howard.
So thanks, Shawn. Happy to be here today. I am in San Antonio, and very happy to both have won this award, but really looking forward to, moving our nation forward in terms of global manufacturing competitiveness. And as we do that, how do we do that in a very cyber secure manner so that we protect our U.S. assets and IP in ways that, again, just lead to our manufacturing sector becoming ever more globally competitive and dominant.
Thank you. And that will be an excellent segue for us talking about competitiveness of global manufacturing. And then finally, I want to introduce Leo Simonovich. So Leo works for Siemens, one of the world's leading manufacturers. And he's their head of their cybersecurity product line for Siemens Energy. And he basically has built that product line over the past 3 years from a nascent cybersecurity line to now somewhat of an industry powerhouse, making plays for cybersecurity manufacturing. Leo.
Thanks, Sean. Glad to be here. Many of you may not know Siemens Energy to be a cybersecurity company. Siemens is known as a 173-year-old engineering company. Well, over the last decade, we, by necessity, have become a cyber company focused exclusively on operational technologies. We very quickly recognized two things. First, that we cannot go at this problem alone. And then secondly, that we needed to build an offering that went beyond the box, that helped us secure the complete operating environment. It is no longer sufficient for us to think about product security as a linear problem. We need to think of it in an innovative way that helps us cover both the brownfields and the greenfield environments. So look forward to the conversation here on how we're transforming ourselves and also helping our customers.
Excellent, excellent. So I actually want to, I'm going to come back to that product security and concept of a linear problem. But for the moment, I'd like to pivot to Chad and Howard and talk a little bit about this CyManII award that the Department of Energy did. And can you, Chad, start maybe give us a background on the award, and then Howard, can you pivot and tell us, you know, what does that investment look like for UTSA?
Sure, Sean. So the Advanced Manufacturing Office, you know, in looking at ways that we could help U.S. manufacturing continue to be competitive and more energy efficient, we recognize that automation and other smart manufacturing technologies are really important to pushing that forward and helping industry become more energy efficient and more competitive. And in addition to that, the integration of the supply chain and helping the supply chain work together better were key issues that increase the number of connectivity points and thus increase the risks to cyber intrusions. And so with that in mind, we went forward with a funding opportunity that focused on automation and securing the supply chain, and the education and workforce development around those two areas as well. The University of Texas San Antonio had a really great project team and a very good application, and they won the competitive process to fund a new institute. We the Advanced Manufacturing Office this will be our 6th Manufacturing Innovation Institute, and these are supposed to be national networks of multidisciplinary teams from industry, universities, national labs, nonprofits. And we want to break down some of the silos that are out there in developing technology to address cybersecurity, and bring together a large team of facilities, small manufacturers, large manufacturers, universities, and a very, very diverse team in order to tackle these issues on an industry scale, so that it touches a wide variety of industries that use a lot of energy for the United States.
Excellent. Howard, how does that actually look, Howard, at UTSA?
Well, this is a huge win, if you will, for the University of Texas at San Antonio. We put our heart, our soul, and our, brains into winning this process, not only for the university but for the region and the country. In terms of energy usage, and some of the listeners might not appreciate this context, our institute is a cybersecurity institute, but it's also funded by the Department of Energy. So at the very core of of our institute, the Cybersecurity Manufacturing Innovation Institute, hence CyManII, at the very core of our institute is not just about cybersecurity, but how we gain energy efficiencies in manufacturing. And as I often like to explain to people, if you look at the total US energy utilization on an annual basis, we use about 100 quads of energy. And about 26 of those, or almost a quarter, or over a quarter of that energy is used in US manufacturing. So we can use digital technologies to really increase the efficiency of that. And we think by doing so, we can conservatively estimate, a quad of energy saved on an annual basis. I'm sorry, cumulatively over 5 years. So if we do that, though, we expand exponentially the cyber attack landscape. So the real question is, how do you invest in that cybersecurity in a new way? And the genius in my mind of the implicit, maybe not explicit, but the implicit assumptions made in the funding opportunity announcement was it forced our team, to really think about, how do you invest in cybersecurity to obtain an energy ROI, for your company. And really it's solving that problem that I think is a unique aspect of what our institute will focus on. We are out of the box. We're very large. We have over 20 universities engaged, 3 national labs, the Idaho National Lab, Sandia National Lab, and the Oak Ridge National Lab. And we have a multitude of companies, including, our guest, Leo from Siemens is one of our members. But it's really that energy ROI that is going to be, I think, a central feature, of our institute, and creating that reason for folks to invest in cybersecurity. And I'm sure as we go on, we'll have some time to talk about the technical innovations as well.
So that was a great point. I mean, manufacturing in America is $2 trillion. And that's 12% of our GDP. I mean, that's huge. And so when we think about that, and Leo and I have talked about this separately, when we talk about changing culture, you said something that is very key there, cybersecurity for energy return on investment, so ROI. Changing that thought dynamic is interesting, and that's a philosophy change in the market space. Leo, you've been leading that charge for at least 3 years. Can you talk about how you've seen that dynamic change, and then what you've done to lead that?
Yeah, so the typical calculation for cybersecurity is loss avoidance. And in the operational technology space, it's a lot of loss. We're talking about shutdowns of energy production, and we're also potentially could be talking about safety events. At the same time, though, there's a revolution underway to transform our energy system, to make it more clean, to make it more reliable, make it more distributable. And at the core of that, of course, is digitalization. Over the next 2 years, we're going to add almost 3 billion smart devices to the energy system. And each of those devices creates a potential vulnerability or a node that could be exploited for malicious gain. To realize the benefits of digitalization, we have to think about cybersecurity differently. We cannot think of it as only a cost. We have to think of it as an enabler, and we have to think of it as a competitive advantage, not just for manufacturers like us that have become digital companies, but also for utilities. We think of utilities becoming digital companies as something that is out there in the future. But the reality is that many utilities today are using advanced software to optimize the energy system and to deliver reliable energy across traditional fuel sources and new fuel sources. And what that means is that in driving optimization, they happen to deliver electrons, but in reality, they're digital companies. And therefore, cyber has to be at the core of their and our business models. It begins with the simple premise that, sure, we should recover the cost of cybersecurity, and that we have to provide some transparency into that. That's the first stage of the evolution. But really what we need to do is advance the game to get ahead of attackers. And to do that, we have to think of what are the competitive features of a robust cybersecurity program. That if you're a customer and you think about, am I secure? What are the elements of that? And the big element, of course, is visibility and detection and getting ahead of attackers. So we at Siemens, to answer your question more directly, Shawn, I've been thinking about how to provide visibility, context, insight, so that we can quantify the risk, but then ultimately so that we can also think about how to unlock digital value. Because once we understand the risk, we can begin to make smarter choices about where to invest our dollars.
So that's a great point. And when I hear that from when I hear about competitive features from a government standpoint, my mind goes framework. How do we, because it's not scalable on a government perspective to individually do things. So I think of what is that universal framework for the product security. And so Chad, what are you guys thinking about at AMO, and how do we build that cybersecurity framework and product security?
Yeah, so adoption of new technologies that require this connectivity and this data-driven approach, really it increases the risk, and we want to make sure that we are promoting technologies that allow people to adopt these new technologies and not introduce new risks into their processes. And so, we really are about enabling companies to safely be able to adopt new technologies and safely be able to have these new points of integration. So our goal is really to enable the safe adoption of new technologies that are rolling out, so that our U.S. manufacturing can be more competitive in that space.
Great. And when we think about data, data models and driving the data analytics to provide security and increase the efficiencies, is that not the typical workforce that we're thinking about? Howard, when you're thinking about that, I mean, are these different students, leaders, and players that are not traditionally in that energy sector space of manufacturing?
Well, the technical and educational workforce development aspect is huge, and certainly was a major component and is a major component of our institute going forward. I mentioned that we had over 20 universities engaged. As we build out our institute over the first year, we're definitely going to be reaching out to multiple state community college systems and other MIIs, and really leverage some of their expertise and their student base, if you will. So, a big part of what we're going to be doing in terms of the funding that we're going to be providing is to develop the technical innovations, that lead to this cyber secure environment that Leo and Chad have talked about already. We call that the secure manufacturing architecture that we'll be doing in an iterative fashion over many years. However, as we do that, we also recognize fully that as you introduce new technical innovations, you've got to do an incredible amount of education if that new architecture, if you will, is ever going to be utilized. So you have to not only train the students, that develop the SMA, and at the graduate programs across the country, but you also, to put it, as Chad said, if you're going to enable a safe adoption at the industry level, you've got to educate that workforce as well. So we have a dual-pronged EWD approach that really generates the technical innovation at one level, but it enables the installation of that innovation, at the small, the medium, and the OEM level manufacturers in the U.S. We call that TrustWorks as a service. So we're going to model that after what's called a B corporation or a for benefit corporation. And companies can, expect from us, to go in and, show them exactly how much energy they're going to be able to save by investing in, specific technologies. And then TrustWorks EDU as a service will go in and educate their workforce, their incumbent workforce, on how to optimize those innovations on their environments and in their supply chains. So it's a huge component. I mean, as we developed our technical innovations, it was very clear to us that if you're going to transform the marketplace, you must parallel our technical innovation activities with how do we bring people up to speed and how to use those technologies in the factory floor, as well as the next generation of workers as well.
One of the things I was thinking about right there is you just talked about the ecosystem of the workforce, the fact that you have OEMs, then you have servicing companies, you may have additional companies that provide efficiency services or equipment that works with an OEM. We have, Leo here, who, Siemens is a major OEM. Can you characterize how that, between you and Leo, can both of you characterize what that ecosystem exactly looks like, and why does cyber matter in there? Like, if the OEM does the cybersecurity, where's the third party play in? It's one of the things we talk about is the connectivity between cybersecurity at the third party and cybersecurity at the OEM. Can we talk about that for a minute?
Yeah, maybe I'll start, and Howard, feel free to jump in. If we think about operational technology and the skill set that's required, we're talking about experts that understand control systems, that understand networks, that understand mechanical equipment, turbines, switchgear, and that can put the pieces of the puzzle together between the physical and the digital worlds. Because after all, an attack that sends a command in the digital world has real world consequences. And so much of the equipment that's out there is OEM specific. And it requires domain expertise. That's just the reality of the brownfield environment, and it's changing. Howard talked about a blueprint. That blueprint, let's say for a secure substation, or a secure power plant, or a secure wind farm, requires us to elevate the conversation and to create a cadre of experts that have this blended skill set, and that are grounded in OEM knowledge, so they can interpret what's happening, but then ultimately can zoom out and apply advanced technology, AI, machine learning, or let's say monitoring, for example, and do so in a way that allows us to monitor at the installation level, but also monitor at the fleet level. And the best way to do that is through a partnership. Try and use the word ecosystem. That is exactly the right approach that we need to undertake. We need to cross-train one another on the combination of new and legacy technology, so that we can not only detect well, but also take action in the physical world and do it against the blueprint that helps us understand what good looks like, right? Because part of this is about transforming the brownfield environment, and there's a specific skill set that's required for that, and there's a lot of brownfield out there. And part of it is also thinking about the greenfield environment and what that ultimately needs to look like, the secure power plant of the future. And that's why we need to come together as academia, as OEMs like us, and frankly, IT players and utilities. Because the best kind of skill sets, and because given the unique blend, has to be learned on the job. It's very hard to teach this in the classroom environment, and we have to create cyber ranges, living labs almost, where we're training folks on this equipment in real world scenarios.
What we're going to see here as UTSA builds out, and what the vision of DOE and UTSA is to look like, a lot of people are reticent to think about automation, right? They think that it means that, oh, it's a loss of jobs. But the things that you have just said, and Howard, that you have said, actually sound like, to me, it'll increase the workforce out there. It'll create more jobs in a more competitive America. Can you talk about how does Siemens see these living labs? Howard, can you talk a little bit about what will it physically look like? What is the vision? What is your vision for TSA and those labs?
So there's a couple things that I would start with in terms of what this looks like. So as Chad knows, because he's our technical program manager, and has been engaged with us, from the very beginning. And Chad mentioned that, he's interested in enabling a safe adoption environment. And our institute's response to that in the proposal was one of the pillars of our technical innovation. And we're proposing to put together a nationwide core, and core stands for Cyber Operations Research Ecosystem. And it has elements that Leo has talked about: cyber ranges, test beds, manufacturing test beds. But it's also a very critical component of our TrustWorks EDU platform, because, as I mentioned, we're just getting started, and we're over 60 members, and counting. And how do you aggregate all that? And how do you do it in a trusted, safe environment so that, as we develop innovations along with private companies, because that's how we're going to work together, and with the national labs, as we develop those innovations, we need an environment where we can safely test those in both the physical and the virtual world. And that's exactly what, core is. And it also, big slices of core will be able to be allocated out, to specific individuals or groups of people for, the educational development. So, via core, not only do we have a way of testing and evaluating what the innovations that we develop, if they work, how efficient are they, how much energy efficiency do they gain, because we'll have, benchmarks and baseline efforts that we can measure against. But we'll also be able to let, people in factories, play, experiment with, these new innovations to make sure it works from their vantage, whether they're, frankly, a mom and pop, small manufacturing operation, all the way up to the OEMs. And indeed, when we were in the proposal development stage, myself and a couple key people went out and, organized, listening sessions or road mapping sessions with industry partners, because we wanted to build a proposal that mattered. We wanted to build a proposal that resonated with the industry, because one thing we haven't talked about is that our institute will focus at a fairly young technology maturity level, but we're going to be able to pass that off to industry for implementation. And so, we wanted to be able to make sure, even from the very beginning, that as we thought about the secure manufacturing architecture, as we thought about ways to detect and mitigate, cyber vulnerabilities, we wanted to be able to do so in a way that was relevant, to the ultimate customer, which is, the U.S. manufacturing industry. So we built that core concept up, to really enable that safe exploration of these innovations, to make sure that, if Siemens starts to implement them, Siemens has a very high degree of confidence, that it's good to go. I mean, it's good to be able to be utilized.
To build on that, Shawn, we earlier this year announced a partnership with New York Power Authority to build out a center of excellence that has 3 pillars: a lab, a school, and a security operations center. And we believe that it's this kind of collaboration is what the industry needs to move itself forward. Ultimately, there's a lot of complexity in the system, and we don't know what vulnerabilities will surface or how a potential vulnerability could be exploited unless we deploy technologies, both the protection technologies and also detection technologies, in the real world. And we have the operators test them under different scenarios. Just to give you an example, one of the key challenges today is connected cars and how those connect, or prosumers, and how a grid in which energy flows both ways, from the prosumer into the larger grid and from the large power producer through the system, how that could potentially open up the doors for a potential attacker. So when I talk about living labs, the center of excellence that we built is exactly that. It allows us to leverage the expertise of the operator, the expertise of the OEM, and it allows us to apply advanced technologies. The challenge, I think, for us is how do we do this at a system level? That's really key. And because we ultimately need to understand and answer the question of what the cascading effects and interdependencies are going to look like. That's, in the beginning we said it's not enough to secure the box. Well, it's not enough to secure the plant either. We have to think about securing the fleet. And ultimately, how do we secure the system? And this is where center of excellence, like the one that we're building with NIPA, that will involve the larger community of small, medium-sized utilities, distribution companies, municipal companies that are going to be part of our test bed is going to be really, really, really key.
So, I mean, what both of you said there sounds amazingly promising, but it also sounds like an enormous project. Chad, can you talk to me as the program manager? What are your key thoughts and markers that you're looking for to really carry this forward? Because this sounds amazing, which I really appreciate, but it also sounds like an enormous task for you.
And recognizing this is such a big problem, that is why the Department of Energy pursued an institute model for this effort, which is $70 million of funding over 5 years to bring together this very diverse group of universities, industry, and other stakeholders, so that you're not just getting the research side, but you're also getting the implementation side. And so we recognize how complicated that problem is, and so that's why we pursued this institute model. Being the Department of Energy, we really were pushing energy efficiency goals, and so all of the outcomes need to be driven towards energy efficiency. But we also are pushing things like vulnerability disclosures and how the industry is working together with those. And so we asked CyManII, the UTSA team, to put together, what their goals are, and they put together some very aggressive goals for saving energy as a result of their cybersecurity measures, but also very aggressive goals in educating the workforce and getting secure technologies rolled out. And so we, the Department of Energy, we asked the applicants to really come forward with goals, and UTSA's goals are very aggressive, and they've got a lot of work to do over the next 5 years.
That's good. Hey, it's never a bad thing to put out a big challenge and really go after it. I wanted to raise up the strategy discussion a little bit and talk about why supply chain security in manufacturing matters for the United States. I'm a threat intelligence guy and intelligence member through my career history. And so what our adversaries are doing matters to me. And I pay attention to that when we talk about reducing risk from cyber. Can we talk about a little bit, and maybe Leo, you could lead, since you've built your the cybersecurity product line for Siemens, and talk to us why holistically does this matter against our adversaries in the global framework?
Yeah, well, it boils down to trust and the ability of parts of the energy system to interact with one another. So operators trust the data flows that are going to the OEM, and for the producers that are on demand, linking up to the energy system, to trust the energy system as a whole. What that boils down to is a simple statement: we're only as good as our weakest link. And that's why securing the supply chain, especially the tail of the supply chain, becomes really important. Well, we may say, well, certification is the answer. Certification has an important role to play, but ultimately you're certifying a component without understanding how the component ties into the larger supply chain. And what we found with our suppliers, at least, their toughest challenge was not securing that component, but thinking about how to mature their overall cyber program. They needed a roadmap to think about this problem. And ultimately, we need to lift the middle. We need to lift some of the smaller entities that are in our supply chain. Some of the recent attacks that we've seen in 2020 and 2019 started with the smallest entities in our supply chain, and then cascaded out. So it's really key that we address this problem more holistically, and that we do it in a way that allows us to leapfrog a little bit. Because if we're just closing vulnerabilities, we're always playing the catch-up game. Secure by design should be one principle. Understanding the interaction between data, assets, and people, especially in this new digital system, should be another principle. And then having some control points around it. And then third, there's technology out there today that, for example, we're working on artificial intelligence detection to get at this issue visibility, so that we're able to get at the problem faster. And inform the whole supply chain of what's happening.
And frankly, it sounds like that ecosystem of CyManII and this award that Howard's building out will shorten that OODA loop, right? The decision-making process loop, just by nature of bringing, bringing the workforce together to discuss this product security issue is by nature going to stretch out into the greater community there. And I like that you brought up certification, and I think of certification and compliance. Now, we're not, I mean, Howard, I don't think you're saying this, but could you discuss a little bit? Do you think that you'll come out of this maybe with some technologies and some certifications? Or how do you think that it'll play on the workforce angle? How will we actually grow? Will there be new courses out of this? Potentially new majors in the universities? Where do you see that, Howard, on the education side?
Yeah, I think that there's definitely some pivoting that will occur. And I can honestly say that during the past year, as I, led the team to, generate this proposal and now starting on the innovations, it has sparked a tremendous amount of dialogue, amongst, these 20 universities that I keep mentioning, the Purdue's, the Illinois, the Carnegie Mellons, Clemson, Mason, the list just goes on and on. But a lot of us have come to really, even though we have existing engineering programs and aspects of this, it's very apparent to our team now that there are less, if you will, holistic approaches. So for instance, Leo just mentioned a secure by design approach. I mean, that's heart of a big component of how we've thought about the secure manufacturing architecture is, how do you bake this cybersecurity into the system? And when I say system, and it's really a system of systems that we're baking that into, we're linking the physical layer with the cyber layer, and people think in those terms a little bit already, but we have a third layer, and that's that energy efficiency level. And we realized as we thought about how to design an architecture that we could link the data flow between those three layers in a way that could achieve the energy efficiencies that DOE wants us to achieve, but also increasing the level of cybersecurity enormously. We in the SMA, we really go back to the fundamental physics and the fundamental mathematics of how systems operate. The approach is radically different than the typical cybersecurity approach, that's out there today. And I think as we go through this, we will understand, that the SMA really bridges let me answer it this way. The funding opportunity announcement asked us to secure automation and secure the supply chain. As we thought about the fundamental physics of these systems of systems approach, we realized that might be an artificial construct, that there was a way the SMA could actually integrate across the supply chain and create what we termed a digital passport. So we can devise a supply chain that's, rooted in trust, and every aspect of that supply chain is known to the final assembler of the manufactured good, if you will. So, if you think just about, the supply chain approach today, if you look at universities and how they train people to think about supply chains, it's really a logistics-based approach. It's not a approach built on the realities of, what we're even dealing with today, with the COVID-19 and how that's disrupted our supply chain. So I think it's going to force some, very fundamental rethinking. And, I know at UTSA, I've been asked, for instance, to put together a Texas-based legislative action request that will fund, one of these new types of engineering programs focused on the supply chain itself. that looks way past the logistics and the cost savings, but really, how do you build, and to use a word that's overused today, but how do you build resiliency into your, and adaptability and the ability to pivot quickly? How do you do all that? And I think that's going to take fundamentally a different approach. And so there's some factors that have, collided here, if you will, that, kind of force that new thinking to occur. It'll take a while, to get concretized, if you will, but it's certainly, I think, on the way.
I like that. I like that. All right. At this point, we're coming up on our hour. I always think when I've done these types of webinars, I always think, what was that one issue that I wanted to point out? I call it a stray electron. That one point that I wanted to drive home, or that one issue that we may have not covered yet, but is very valuable for the discussion. I just wanted to go through with each of you and give you an opportunity to hit that stray electron. So Chad, would you like to lead us off?
I think the one thing that we didn't talk about is I want to encourage the audience to get involved. This new CyManII Institute's getting stood up, and we're doing some great work. And I want to encourage all the audience, whether you're industry or university players, to get involved in it and reach out and become a member of the institute and contribute, because we really want to see this transform U.S. manufacturing and make it more competitive, more secure going forward. And for that to happen, we need input from a wide diversity of players.
It's a great point. Great point. Leo?
Yeah. So cybersecurity jobs are energy jobs, and they're also manufacturing jobs. They're one and the same. And it's key that we train software engineers differently than we did in the past. Howard talked about a different way to think about supply chain, not think about logistics, but think about data. The supply chain of data and its security, its flows, data at rest, data at edge, how data flows between the physical and digital worlds, and how we think about detecting those flows, measuring them, and then ultimately taking action on them is at the core of the curriculum that we need to build in a cadre of professionals that will enable us to become ultimately more resilient.
That's great. I like that. Howard?
We have touched on it a bit already, but I think the bottom line for me, and what I will leave the Institute happy, if you will, if we've done nothing less than transform U.S. manufacturing. And by that I mean, how do we make it much more energy efficient? How do we make it much more digitized, but in a very, very cyber secure manner? And how do we educate that next generation of manufacturers and the engineers that design the systems for the manufacturers? I think this is going to be a very it's a different way of thinking. And at the risk of my university friends, and I'm a university person, but I think that, the reality of what's facing our nation right now is really going to force it's going to be a forced function in terms of how universities and how, we collaborate with manufacturers to really move the needle forward. And I'm looking forward to that. I think it's a fantastic challenge, and, it certainly is a challenge, but, it's going to be just a lot of fun and with a lot of impact, going forward.
Howard, I love that ambition. I mean, I'm excited about this award. I'm excited about the work that DOE is doing, and Siemens and UTSA is doing. that type of leadership and statement that you're making, I think is an excellent way to charge ahead and really move the needle as you described. So thank you for that. I'd like to thank all of you for being here. My fellow DOE member, Chad, thank you so much for being on this panel with us and really describing this award and DOE's goals. And of course, Leo, thank you so much for being the OEM, being the industry leader, and leading Siemens through this change, but not only Siemens, but America's energy and manufacturing core that you've been driving for a few years now. So thank you all three of you for your time today.